Hi, and welcome back to Network Training. Now, in this section, we're going to learn about the requirements in terms of multicast and in terms of bandwidth of your AV traffic. Because what you're going to find, particularly in more complex systems, with more encoders, more decoders, more traffic on the network, we really need to start thinking about what are we going to need to do in terms of multicast, and do we need to plan a bit for larger bandwidth traffic going through our network. Now, we're going to start off talking about multicast and just talking about some of the protocols that are going to require that we have multicast working properly, starting with something called QDP. Okay, and this stands for Q-SYS Discovery Protocol, and it's one of the few proprietary protocols that we have inside of QLAN. Okay, now QDP is used for Q-SYS cores to be able to discover all of the other Q-SYS peripherals on the network. And essentially, it works a little bit like this, okay? All of the devices are going to speak to this multicast IP address, 224.0.23.175, okay? Don't worry, you don't need to remember that. I don't remember it. I just read it off the slide, okay? It's all going to be shared in the documentation that you'll get at the end of the training. But essentially, all the devices go onto that address, and then your Q-SYS core brings all of that off. It subscribes to that address, so the core builds a picture of every Q-SYS device that's on the network, which is also what your laptop does. If you're an AV programmer and you connect your laptop, you also have your laptop running Q-SYS Designer software, building a picture of all the Q-SYS devices on the network. Okay, so that's really important. If QDP isn't working, then we're not going to have anything else working, because the core is not going to be setting up all those connections because it can't discover the devices. Now, the next one, of course, we've already talked about this in terms of latency and consistency, but this is also multicast, PTP v2, okay? Because, of course, this is where our clock leader is talking to all of the clock followers all at once. So, of course, multicast is going to be used, just like in any situation where we want to go from one transmitter to many receivers. Multicast is going to be the most efficient way of doing this. So the key things in terms of AV over IP and multicast is that the AV devices really must receive the necessary multicast. They must receive things like PTP and QDP and some media traffic, which is going to be multicast as well. But also, the multicast bandwidth must not exceed the device limits. For example, if you have a 100 megabit per second port on a device, you want to make sure that if you've got a reasonable amount of multicast floating around the network, you're not sending all of that to every device at once. So we are, of course, going to need to use technologies like IGMP snooping to make sure we filter our multicast and only send it to the devices that it needs to go to. All right. So we're going to now compare our different protocols in terms of their multicast requirements, but also their bandwidth. Because protocols like QDP and like PTP, they are multicast, but the good news is they're not particularly high bandwidth, okay? And that's quite important because some traffic is going to be high bandwidth. So we might think at this point, well, we've only got low bandwidth traffic, so do we actually even need to filter this? Why can't we just sort of flood all the multicast and it'll all work, right? All the devices will get the traffic they need to get. You might get away with that with QDP and PTP on a smaller system, but when we add in video, that's where that might not work quite right, okay? So let's take a look here at Q-SYS Video, which is also multicast. Actually, it's worth pointing out with Q-SYS Video that if you program it so they're only going from one encoder straight to one decoder, and you're not going to multiple destinations, it will actually set it up to be unicast, which is kind of helpful. But in most situations, the reason you want to use video over IP is because you can send it wherever you want to. In which case, we should probably assume that it's going to be multicast. So here we can see an example of that. We've got an encoder. We've got the video stream in the network, which is this white box here. Okay, that's where it goes to multiple decoders. And we use a protocol here called Q-SYS Shift. Actually, it's more accurate to say it's not really a protocol, but this is the way we actually encode the video traffic. This is our video codec that we use for Q-SYS. And this is where we're getting into potentially high bandwidth territory. However, it's important to note that Q-SYS Shift is quite a bit less bandwidth intensive most of the time than some other AV over IP video codecs, okay? Because let's face it, if we're in a kind of meeting environment or a corporate environment, we're probably not sharing the most exciting videos in the entire world onto our screens, okay? It might be something like a spreadsheet or like a PowerPoint or something like this, where there is some motion, right? Me moving around, but if I'm not moving, then you can see it's pretty much a still image, okay? And Q-SYS Shift takes advantage of that. Basically, it scales the bandwidth depending on the content. So for mostly static content like this, it's going to be using far less bandwidth than some other codecs that you might find. However, if you do decide that you want to play a 60 frames per second 4K nature documentary or something like that, then it can go up to around 750 megabit per second. And it's always dynamic. It's always moving between low bandwidth and fairly high bandwidth, depending on the content, okay? So when we're planning for bandwidth and thinking about multicast, for static content, you're going to find that it is around 10 to 30 megabit per second, even at quite high resolutions. It's not going to go much beyond that. But it can go up to 750 megabit per second. Now, of course, that means that all of these decoders are going to be receiving that, okay? Now, what about if we have multiple encoders? So let's say that we have here encoders A and B, and they're both going onto the network. This is where IGMP snooping is going to come in. And IGMP snooping is essentially going to mean that our network speaks to all the receiving devices, all the devices that want to receive multicast, and it says, do you want to receive it? Do you want to receive it? What about you? And those devices can respond. They can also ask for it specifically, and they can say, yes, I do want that multicast, or no, I don't. So this is very efficient. Basically, all your multicast gets registered here at the IGMP querier, and then your decoders are going to say things like this. Okay? They don't really say anything. It's just for the PowerPoint, all right? They don't really have speakers, but only little voices that say, I want to join this stream. But this one here is saying, I want to join stream A. This one says, I want to join stream B. And they say that to the network switch, the switch that's running the querier, and then they're going to get the traffic that they want to get. The problem occurs if you don't have IGMP snooping. So if we were to say, we're not going to worry about filtering our multicast, then this is the kind of thing that might happen. So here you're going to see that we've got two encoders. Let's assume they're both going at 750 megabit per second. Now we're going to find that basically our decoders are all going to receive 1500 megabit per second. Everything actually on the network is going to get all the multicast. So it's going to get 1500 meg, and it's all going to be on a 1 gig network. Okay, all of our devices are 1 gigabit per second devices on the actual device port. And of course, if you add in a laptop to this, it's also going to get hit with around 1500 megabit per second of multicast. And if you've ever had this happen to you, if you've ever plugged your laptop into a network like that, you'll find the mouse gets all laggy and Task Manager says your CPU's at 100%, because it's really having to deal with all of that traffic coming in. So that's why IGMP snooping is really important. So let's look at all the multicast we might come across and how it works in terms of what's multicast and also what's high bandwidth. So here, if we start with QDP, which we already looked at, it's multicast. It's not really that high bandwidth. It's actually 1 packet per second, and each packet is just like, hi, I'm an amplifier, I'm a Q-SYS core, and this is my IP address. It's really small amounts of traffic. PTP, higher data rate, but still really small packets, so low bandwidth, but it is multicast. When you get into Shift, that's really on the opposite end of the scale. So Q-SYS video, multicast can be reasonably low bandwidth. It's not really low. It's like 20 to 30 megabit, like we said. That's really the lowest, up to 750 megabit per second. QLAN audio actually is always unicast. Between Q-SYS devices, that's always set up as a unicast connection, which is kind of handy. And it's not high bandwidth, but it's kind of a few megabit per channel, essentially. And Dante is kind of similar sort of bandwidth, but Dante can be unicast or multicast depending on how you set it up. And the bandwidth for both of those, roughly the way you can think of it, is 16 channels is around 25 megabit per second. You can have up to 512 channels going into a Q-SYS core on the biggest Q-SYS core, and 512 channels going out. And that's around 850 megabit per second. Okay, so in a really heavily utilized system, you could have a lot of audio going to and from the core, and you could have a lot of video, but remember that the video doesn't go to the core, it just goes to the device that actually needs it. Okay. Now, let's take a look at how IGMP works with multiple switches, because with a single switch, it's pretty straightforward. You turn on IGMP snooping. There's a few other settings as well, but you don't have to worry so much about things like where is your querier, right? What does that really mean? Let's take a little look. So here we have multiple switches, okay? And what you typically do is you have IGMP snooping on all your switches. So all your switches are filtering, but you only have a single IGMP querier in the network, okay? So for example here, we might have this kind of core switch here with a few other switches hanging off of it. And maybe there's NV devices on these, maybe there's encoders, decoder as well, okay? You only want to have one querier, and that's the thing that's really asking the questions about who wants to get what multicast. If you have multiple queriers, you might find that's a little bit of a problem. You might find, for example, that your video stops and starts, and the way this would typically manifest itself as a visual symptom is you would get tearing of the video, you might get color shifts, you'll get dropouts, things like that, as the multicast is behaving intermittently. So single querier, but all the switches are filtering. And remember that typically, not always the case, depending on what switches you're using, but typically with IGMP version 2, all of the multicast is going to go to the querier switch, even if it doesn't need to get registered. Okay, so just think about that as you think about your kind of uplink bandwidth, particularly if you've got a lot of video going on. Now we've got a decoder saying, I want to join a particular stream, and you can see there, of course, that encoder is going through the core switch, and then it pulls it down to that decoder. Now, how does this scale up with larger networks? Well, it's kind of the same concept, but we're going to have multiple layers of switches. All right? And we want to make sure we design this so we don't have too many switch hops, but a pretty standard network design would already account for this. Okay? But here we've got, let's say, 3 NV devices, 3 video devices, maybe there's 3 more, a bunch over there as well. Now we definitely need to start thinking about our uplink bandwidth. Now remember, the video devices themselves, they are 1 gigabit devices maximum. So that means that you might need to think about the uplink as being more like 10 gigs, something like that. And in this example, we've actually got a redundant core switch set up, which you can do, of course, if you want to. And there's going to be a link between those. So maybe that's going to be, you know, another level up. So maybe that's a 25 gig link between those. This is all fairly kind of logical stuff, particularly if you're from the IT world. It's just something we want to make sure we think about as we have lots of video on the network. We're making sure that we kind of oversize our uplinks a little bit. And of course, if you go up another level again, now maybe you've got these access switches, you've got the aggregation layer, and you've got redundant core switches at the top there as well. Now you might go from 10 gig here, 25 gig there, and 40 gig between your core switches. Just think about how many video devices you've got today, how many you're likely to have, and make sure you've got enough bandwidth for those in your uplinks. Now, one last thing on multicast is the actual ranges of addresses that are used. So sometimes in the world of IT, you want to maybe restrict certain addresses or only allow certain addresses, rather than just saying all multicasts is fine. You might say actually only specific addresses are allowed. Well, what you can see here, this is a screenshot from Core Manager, which is the Q-SYS Core's web config page. And on here, you can see that we actually calculate the address ranges automatically. And this is done in a pretty clever way so that even if you've got multiple different Q-SYS systems on the same network, they won't have overlapping ranges or duplicate addresses for different video encoders, for example. And you can see right here that we can set that to manual as well. So if you said, I want to make sure the video endpoints are only in this multicast range, you could do that, but typically these are just left as automatic. And of course, they're not going to just change suddenly. So you could also, if you're from an AV team, you could give those ranges to the IT department and say, this is what you need to make sure that you allow on the network. So just a little summary there on the multicast and the bandwidth side. Do use IGMP snooping, okay? Even if you think we're probably okay, we haven't got that much multicast, you might have in the future, and again, it's just something simple that we can turn on that means we're, in a much more robust environment for AV on the network. One querier per network, okay? But you want to have IGMP snooping on all your switches, and just consider the uplink bandwidth for audio, but particularly for video. That's it, that's the end of this section, but join me for the next one. I'll see you there.